Sequences can be also defined recursively. Recursive means if I have a few terms in a sequence that are next to each other or a known distance apart, I can use those terms to define the rest of the sequence. So this is like one step more difficult than an explicitly defined sequence. There's a few examples of this. Here's the first. Our goal is to find the fifth term if the first term is 1, and then we have this expression here. What you'll see here, this is a sub n minus 1. And then I have got 2n and minus 1 at the end. So this is not a n minus 1 over here either. It's 2n. This should be a bigger n, just to make sure that it's not subscript. Minus 1. So we're going to find the fifth term. So let's just walk through it really quickly. Let's find the second term first. So my second term is a sub n. N is 2 here, so 2 minus 1. That's what I had. So that's 1 plus 2 times n. N is 2 minus 1. So my first term is 4. Does that make sense? The 1 minus 1 kind of takes care of itself. Now a sub 3. A sub 3, we have to use this because a sub 3 relies on the second term. So that's 4 plus 2 times 3 minus 1. 4 plus 6 is 10, minus 1 is 9. A sub 4 is 9 plus 2 times 4 minus 1. So 9 plus 8 is 17, minus 1 is 16. What do we see here? What? Look at these numbers, 4, 9, 16, are going to be hopefully ringing a little bell in your head. So we have 16 plus 2 times 5 minus 1. If the bell is ringing in your head, you already know without doing the math this is going to be 25. 16 plus 10 is 26 minus 1 is 25. Notice how these are the perfect squares. I feel like we need to draw this guy. I hope that's clear. That's the mind blown emoji. I'm trying to connect with the youths. Okay. Find the sixth term. I've just given you a hint. This is a sub 6. That's the sixth term. I've just rephrased. Find the sixth term, comma, a sub 6. If my first term is 3, and then a to the n is defined by negative 2 times a sub n minus 1. So this is all in a subscript where n has to be greater than or equal to 2. So I can't go back. I can't figure out the 0th term. This is defined here. Okay, so let's go ahead and do it. You could go ahead and try to do it on your own. 3, 2, 1. Here's the answer. Okay, I haven't written it yet. So here we go. Let's figure out the second term. My second term is negative 2 times 3. That's this a sub 2 minus 1. That's a sub 1, which is defined earlier. And that's it. So this is negative 6. A sub 3 is negative 2 times negative 6, positive 12. A sub 4 is negative 2 times 12, which is negative 24. And a sub 5 is, we have negative 2 times negative 24. That's positive 48. And a sub 6, negative 2 times positive 48 is negative 96. That's our sixth term. Okay, now I want you to do this one on your own. I've got the first term, and then I'm defining, see this n minus 1, that's always going to happen, or n minus 2, or n minus 3. I'm going to have n minus something in a recursively defined sequence. So if a sub 1 is 8, and a sub n is equal to 2 times the quantity of the previous term, minus 7, and n has to be greater than 2, what is the sixth term? Let's go ahead and do it. You can pause it. 3, 2, 1. We're going to do it. All right. So my second term. 2, my previous term. This is that a sub n minus 1. That's my previous term. So that's 8. 2 times 8 minus 7. Okay. So 16 minus 7 is 9. My third term is 2 times my previous term, which is 9, minus 7. So 18 minus 7 is 11. A sub 4, my fourth term, 2 times 11 minus 7. 22 minus 7 is 15. A sub 5, my fifth term, is 2 times my previous term, which is 15, minus 7. 30 minus 7 is 23. And the last term I'm looking for, my sixth term, is 2 times the previous term, 23, minus 7. 46 minus 7 is 39. This is interesting. Okay. Let's talk about our last sequence of this video. It's called the Fibonacci sequence. The Fibonacci sequence is often described recursively. See if you can find a recursive formula for the Fibonacci sequence. Here are the first 1, 2, 3, 4, 5, 6, 7 terms of the Fibonacci sequence. Can you come up with a formula for the Fibonacci sequence? A recursive formula that's using the first few terms. Okay, I'm going to give you the answer in 3, 2, 1. Here it goes. So we're going to define this. We could define it as the first or the 0th term. This is the first term. This is the second term. This is the third term. We don't necessarily have to start. It's kind of arbitrary whether I call this the 0 or the first. I could do either way. I'm going to use the 0th just because that's what the book uses. So we're going to say I have a sub n minus 1 plus a sub n minus 2 is equal to a sub n, where a sub 0 is 1 and a sub 1 is 1 as well. These should probably all be lowercase. I don't know if it really matters. Okay, I think that's pretty good. Let's look at the past recursively defined sequences. I think that's good because what this tells us is I can find any term a sub n using the previous two terms, knowing the first two terms. We should also say n has to be greater than or equal to 2. So this in total is the recursive formula. Okay, that is enough of this video. It's going to take a really long time to upload. Hope y'all are healthy and well. Let me know in the Google Classroom what's working for you. We are going to get through this together. All right, have a good one.